So in this video, we're going to talk about how to determine whether or not a molecule is polar or nonpolar. Now, it presupposes you know how to draw Lewis structures. So if you're still not confident with drawing Lewis structures, you need to go back. You also need to be familiar with geometries as well. So when we talk about a molecule being polar, what we're referring to is that there's a buildup of positive and negative charges on different sides of the molecule. So it looks like a magnet. We've got a north pole and a south pole. And generally what we're looking at are electronegativity differences as well as issues related to geometry. So let's say we go back and we draw formaldehyde. We drew this in an earlier video. We've got COH2. Now what I like to do is I like to draw arrows to point the way which way the net electrons are moving. So what I'm going to do is I'm going to draw an arrow, and it's going to point from the least electronegative element to the most electronegative element along a bond. So if it looked like something like hydrogen-carbon, okay, hydrogen is my least electronegative element, carbon is my most electronegative element, so I'm going to have a movement of electrons from the hydrogen towards the carbon. Same thing's true on the other side. And if I look at carbon and hydrogen, what I see is that carbon is losing its electron density to oxygen. So if I look at the arrows and I place them tip to tip along the central atom, what I see is that overall the electron density is being pulled from the bottom part of this molecule towards the top. It's moving from hydrogen to carbon to oxygen. So if I looked at the electron density, I would see that most of the electron density is here at the top and the least amount is here at the bottom. So I could effectively draw my magnet. I've got my north pole and I've got my south pole. Now let's look at something like methane, CH4. For CH4, I've got my central carbon atom. I've got 4 periphery fluorine atoms. And I've also got a tetrahedral geometry. Now if I start putting my arrows together, I have all the arrows pointing away from carbon. So as I look along each bond, each fluorine atom is pulling electron density away from carbon. But if I look at this in 3 dimensions, basically I have an outer sphere of negative fluorine atoms and an inner core of a positive carbon atom. So I don't have a polar molecule in this case because there's really no net direction. The fluorines have all pulled them out towards this outermost edge of this molecule, so the whole thing looks negative. There isn't a north pole or a definitive south pole. So qualitatively, how can you quickly figure out if you've got a polar molecule? Well, the only real thing to do is draw the Lewis structure, but there's a few guys to help you. First of all, typically if you're going to have a polar molecule, you're not going to have the same periphery atoms. So if you look at something like CF4, CH4, BH3, these are all molecules in which all the periphery atoms are the same. The second thing you want to look for is the geometry. Now, if you have all the same periphery atoms and you have no lone pair sitting on the central atom, this means that you have a nonpolar molecule. There's no possible way that you could have a net direction because they're all pulling equally. If you do have lone pairs sitting on the central atom and you have the same periphery atoms, you're going to have a nonpolar molecule if it's linear in terms of its molecular geometry, if it's trigonoplanar, or if it's square planar when you finish. Those are the only 3 cases where you can still have lone pairs on the central atom and still get a nonpolar molecule. Otherwise, everything else, particularly if you have different periphery atoms, they're not all hydrogen or not all one element, and if you have lone pairs on the central atom that don't give you linear, trigonoplanar, or square planar, then in that case what you're going to have is a polar molecule.